All right, let's get going and people will join when they can. Thanks to everyone who is joining us today. My name is Dalia Spasova. I'm part of the developer marketing team here at Kong, and I would like to welcome all of you to our May Kong Gateway online user call. So for today's presentation, we have a special talk for you coming from Wangchong, Zhou and Enrique, Cota. They're both senior engineers here at Kong, and the topic for today will be improvement and feature sneak peek of Kong Gateway 3.0. So exciting stuff. At the end of the presentation, we will open it up for Q&A and discussion. You'll be able to unmute yourself, turn on your video, but please feel free to drop your questions in the chat during the presentation, and we will answer them at the end. So with that, I'll hand it over to Wangchong and Enrique to start the presentation.
Cool. Hi, everyone. My name is Wangchong. I'm working for Kong as a gateway engineer. So first of all, let's talk about unified gateway runtime. So so after 3.0, we're going to introduce a new concept called unified data plane. Unified gateway runtime. The runtime here is all the Lua scripting files, C libraries, and all the binaries into run Kong. So before we get to the topic on why do we do this, let's have a look on how we're doing it right now. So for enterprise version, we have it being forked by the open source version. We call it the OSS fork. And all the enterprise features and plugins, all the stuff being implemented as we call it intrusive fork, which all the codes are spread all over the code space. And this is causing several problems. The first one is the merging complexibilities. For example, we want to release C and E for the same time in the same release cycle. And we have to resolve these merge conflicts every time we're doing the merge. The second one is about development velocity. So imagine you want to develop something, you want to put into either enterprise or open source version, and you need to open maybe two PRs or more to both of the repository and get the reviews and merge, and maybe also addressing some comments on both sides. It's causing a headache, obviously. The last one, and also I would say the most important one, is the user experience. So when people want to switch from C to E, switch from the open source version to the enterprise version, you will need to do the menu migration, and you cannot just install the enterprise on top of C and make it work. So a lot of features like RBAC and those workspaces are very deeply coupled and distributed into the code space. Next slide, please. So what I'm trying to do after 3.0 is to introduce something we call a meta core. So as the graph showing here, the meta core be just very lean and unified runtime. You will have a balancer hook, for example, and a router, also chaser. It will implement the predefined hooks inside the code space, and either the open source version or the enterprise version will just become an extension to the meta core, and all the features like plugins and even the core features are being implemented as extension. And those have several advantages. First of all, it's having a simpler merge effort because you don't have to deal with the merge conflicts anymore. The other side is you can now have a more extensible plugin, I would say. So you can, for example, have plugins for router and balancer in the future. And also, obviously, now you can have less friction between open source version to enterprise. Next slide, please. Okay, so the timeline we're talking about here is a very gradually moved pattern. So we're not going to be deliver this into 3.0 as the first version. This will land slightly later. So we expect it to be arrive no earlier than to 3.1. Okay, so let's get to the next topic, which is the tracer PDK. So as you may already know, Kong already have a ZipKing plugin, and also in the enterprise version, we have a granular tracing support for the 3.0 release. We're going to introduce a new PDK or a new function set we call tracer. It's aligned with OpenTelemetry standard and also have a more extensive interfaces. First of all, let's have a look at what a tracing is, if you guys are not familiar with that. So for example, if you want to follow the requests coming through into your network through different microservices, a typical way you can do is to implement something you call distributed tracing, because all the traces are distributed in multiple microservices. So with this method, you can actually capture the request from the beginning to its end, spanning from multiple places. And there are, of course, a lot of techniques to use, like open tracing, skywalking, and open telemetry. So here, for 3.0, we're choosing the open telemetry standard. There are a couple of reasons we do that. Is the first of all, is the next generation standard to replace open tracing. And also, there are a lot of collection of toolchains like APIs, SDKs, or collectors. The ecosystem is very good, I would say. And also, it gives you the good observability, like spanning from logs, tracing, and also metrics. And you can use it with different API languages to implement the collector. Also, it will be in Golang or JavaScript or C++. And it also have a unified data format, and we call it Open Telemetry Protocol. You can implement it with different exporters, including Jaeger, Zipkin, also all the code providers have. And let's go to the next slide, please. Yeah, so in 3.0, we'll be shipping the PDK, we call it plugin development kit. You can use it to build your own plugin, and also Open Telemetry exporter, OTLP exporter. It will also be implemented as a plugin. And so you also expect more exporters to come after 3.1. So maybe we also do for Jaeger and Zipkin, also Kafka. Yeah, so it's very exciting to see this coming. And the third topic I'm going to discuss is the timer library. Okay, so this is about mostly about our performance boost. So let's first have a look on what the timer looks like typically in OpenResty. Most of the time you'll find using timer is very unavoidable. So you want to do jobs once in a while, or once in a delay, or just to call some like specific API. You want to do maybe call socket in some phases, for example. So let's take the plugin we call HTTP log, for example. So it's the plugin when you send the logs through HTTP protocol. And what it does is just to flush the access log on every request. So what we do right now is to spawn a timer every time it calls this plugin. So every time in a request, it will spin up a new timer. So what we observe is that using the timer is not free. It's basically like a fake request, and also OpenResty stores some context. When you want to access it in the timer, it's not going to give you the O1 compatibility. It's going to be complex as the number of the timer grows. So it's like the ON complexity here. And what I'm trying to do is to introduce what they call a timer library. This timer library will be implemented using the timer wheel algorithm. So it gives you a more scalable timing system. And so basically you will have the two timers, two or more timers for doing the worker. We'll say it will actually execute the jobs you want the timer system to do. Instead of spanning a timer in every request, we just send this job to the timer library, and it will handle it will schedule the timing for you and also execute the result. Yeah, we also did a quick performance test on the timer itself. So it is testing on a modern server without any load on each timer. It just sleep for 100 milliseconds and just continue. So you can see here that our time library compared to the original timer has gained a lot of performance boost, especially when the timers count grows. It basically does not have that much overhead as you experience with the original timer. But obviously in real world, each timer will also execute some computer heavy jobs. So this fraction will become less in the real world. Okay, so after this topic, maybe let's go to something you'll be able to download the ROM on your site. So we'll talk about the images will have a general availability in 3.0. The first, so the two things like FIPS and LNDB I have here is something you might already heard during the previous monthly call if you joined. But this time we're actually making it available for everyone to use. You can actually download and run it on your site. The first one for the FIPS, we're talking about the FIPS 140 here. So it stands for the Federal Information Processing Standard. Sorry. So it's basically something you want to follow for a compliance of your organization if it enforces. So this FIPS image will be a separate offering for the enterprise image. So it will be able to download as a separate image, and it will only be available in an enterprise version. The next stuff we'll have as general availability is the LNDB. So I will also quickly go through the LNDB story we have. So LNDB stands for Lightning Memory Database. It's basically something you store the database in the memory, and it will also map the database into a file system file. So it also kind of persisted it. So we use this LNDB to replace the technique we already have in OpenST, the shared dict. So the shared dict is good for like light uses or like simpler cases where you can have a KV store, but the problem is that it does not have a granular locking mechanism, and also the lock is being spanned across all the workers in this cluster. So by introducing LNDB, we can have a better performance because of the granular locking and also the transaction it gives us. So we also did a slightly quick benchmark with the graph. Next slide, please. Okay, so we tested with the DB-less deployment compared with original shared dict and also MDB. So in this performance, we're testing the workload to read it through the config endpoint and through the memory. As you can see here, the latency almost shrinks to half after we switch MDB. So actually, so this is very simple performance test we have, but the next topic Enrique will bring us and is more about performance details. So I will switch the microphone to Enrique.
Okay, can everyone hear me? I assume that's a yes. So I'm going to start talking about performance. Recently, in the last, I would say, 2 or 3 versions, we have increasingly taken work in making Kong go faster in all aspects. And that's something I want to discuss a little bit more in detail. So initially, when Kong was first released, there was only one mode, which was traditional gateway mode, which is what a lot of people still use, and that is fine. That is fine. It was backed by a database, Cassandra, and then Cassandra and Postgres. But some people started complaining about having to deal with the database on their infrastructure. So we found that implementing a DB-less gateway, which used a file for storing static configuration instead of a database, was a good match for these people. Not all of them, but some of them could use this approach. And a bit later, we released the hybrid mode. It's called hybrid because you have a split. A group of Kong nodes is in charge of dealing with configuration. They do have a database backend, but the Kong nodes that are actually doing the proxying, they are using a DB-less mode. So that's why it's hybrid. Some nodes have database, others don't. This mode is also called control plane and data plane, or CP and DP. So as you can see, the amount of scenarios where Kong has been used or is being currently used differs a lot from customer or from user to user. So asking the question, is Kong going faster, is not something as simple as it used to be when we were just dealing with the traditional gateway. On top of that, all of these individual nodes are composed of workers, and sometimes we want to see what is going on inside the workers themselves. There are other dimensions as well, like how many routes or plugins are we dealing with, and how often do they change? All those things, all those factors have to be taken into account. So the short version is that we have started doing a lot of graphs. Most of those are internal. So this is one example that I find a bit intimidating at the beginning. What's going on here is that we have a bunch of tests being run on a node, a Kong node with multiple workers. The numbers you are seeing here are process IDs. So these are all the workers in one node running several tests. The top left graph, I don't know if you can see it, it's a gray hourglass made of dots. Each one of those dots is an execution of our tests. So this represents a lot of data, a lot of testing time. And we found some expected results and some surprises. The expected result is that one of the workers tends to be a bit lower than the others in the proxying side. That's usually worker number 0, which is in charge of other things besides proxying. So that's why it tends to have a lower number than the rest of the workers. We found that usually our workers have a good variance between them, so that is a good sign. But on the fastest case, we start to see some discrepancies that need to be investigated further. Okay, this is another interesting one. This is related with what Wangchong showed before. This is the LNDB versus non-LNDB comparison. In this case, the good thing is that the blue line is on top of the pink line, and that the yellow line is on top of the green line. That's different versions of LNDB in Community Edition and Enterprise Edition compared with each other, and on different scenarios, 3 workers, 5 workers, 7 workers. So these are the kinds of things we have to do in order to make sure that Kong goes faster. Here is another one. This is a generic test of Kong in gateway mode, Enterprise and Community Edition. We have been testing this since 2.2 until the current master. This graph is from yesterday evening, so we don't have all the data. In particular, we don't have the data of Community Edition master, so we didn't have them last night. Probably we'll have them today. But I wanted to show several things. First, the line goes up. That is usually a good thing, and it is in this case. So we are gaining requests per second as our versions improve. Another thing to notice is that Enterprise Edition tends to lag a little bit behind on the lower end from Community Edition, and the explanation is very simple. Enterprise does more things, but it's also worth pointing out that the discrepancies between Community Edition and Enterprise Edition are getting smaller. Look at 2.2 on the left, and you will see that compared to 2.8, there is much more overlap now. So these are the kinds of things we are testing. The next 3 items I'm going to present are still in development, and we have actually not run these performance measurements for those yet. They will very likely, like 90% likely, land in 3.0, but are still not merged in master. So the first one I want to talk about is the events library. This is a bit of an internal detail about how Kong works. As I said, each Kong node is made out of workers, which are the ones who actually implement the proxying work. They treat each request. So usually they work independently from each other. And that is good. That makes it easier to grow horizontally and add more workers if needed. There is an exception to this. Sometimes we want a worker to communicate something that is important for the other workers to know. For example, in the case of a traditional gateway, one worker might have received the order to create a new route. So the other workers need to know to update their routes. So we need some kind of system to notify the other workers, propagate the event. So how did we do that in the past? So in the past, we had this shared dictionary, which is the way that OpenResty has to share memory between workers, and we would fill it up with events. This has some problems. First one is that the size of the shared dictionaries needs to be known in advance at boot time, so you cannot grow it dynamically. That poses a problem if your dictionary only can hold 13 events, and then 14th event number 14 arrives. Then what do you do? It's also a bit cumbersome for the user. They have to think about, okay, what's the size for the events shared dictionary for Kong? That is a question we would like not for them to have to think about. There is an extra problem. This only happens when you are dealing with lots of workers, like around 32 workers. You start having problems with the lock. Each of these workers write and read from this shared dictionary, which means that when one of them is writing, which is very fast, but still it locks for a tiny fraction of the time, everyone else cannot use this shared resource, which is, as I said, fine until you reach the top, the 32 frontier, more or less. So that's another problem. On top of that, there is the fact that we were using an active pull mechanism. Every worker would have a timer inside, and that timer would periodically go over the shared dictionary list to see if there was anything new that they would have to read. And that is not an ideal way to do this. There is a better, well-known system to do this kind of thing. It's called pub/sub, or publish subscribe. So the first change we are introducing is that now one of the workers is acting as a broker. It is probably going to be that worker 0 that I mentioned before, that does other things besides proxying. So this will be another thing to do on that worker. And what pub/sub does is basically a different way of doing things. It involves first publishing, which is the green line at the bottom. When an event occurs, the broker gets notified. And then it's the broker's job to notify everyone else, everyone that has subscribed to the event that was published will receive a notification or a message, but the notification is being done not on an active wait, but on push. So the broker will push the event to the workers. That means that there will be no active waiting and everything will be faster. This is how it's done, how PubSub is implemented almost everywhere. One particular note here is that the threads that we are using instead of a timer are light Nginx threads, which are not the same thing as a operative system thread. They are much more lightweight and they almost consume no resources while they are waiting. Okay, so that is the first thing I wanted to talk about. The second one is secrets management. We introduced secrets management in 2.8 as a beta. So the whole idea is not having secrets written plain in any place. It can be the configuration of Kong, it can be the declarative configuration or the DB-less configuration. So you don't want to have these passwords or these secrets anywhere. Ideally, you want to store them into a vault, which is a specialized place where you put all your secrets in. So instead of having password 123, you want to have something like this. In this case, I am using the environment vault, which is using system environment variables to store secrets. This is a default provided vault, and it's not the only one that you can use. You can also use HashiCorp or AWS. In order to use the last two, you would have to configure them via our schemas. You have to use either the admin API or declare them in your configuration. So that is a bit of a complexity, not right there. The fact that you declare your entities and your vaults in the same file, but then you use them. That's something we already solved in 2.8. Another thing worth noticing is in plugins. We can use, here's an example of how we can use a Redis password inside a vault. You cannot use secrets in any fields. The fields you can use secrets in are called referenceable, and they are specially tagged. You can tag them or make referenceable fields in your custom plugins, but you cannot put them in any place. They have to be defined as referenceable first. That was the status of 2.8. We have new things in 2.0 and 3.0. First of all, vaults and secrets are not in beta anymore. They will be full-fledged features. And the second one is that we will also provide support for secrets rotation. What secrets rotation means is that if a secret changes on the vault in your HashiCorp or AWS vault, then our control plane will get notified and it will update the data planes automatically. Note about this one, the environment variables cannot be changed. So they can be changed, but they cannot activate secrets rotation. Only AWS, HashiCorp, and others that we will add in the future will have this support. Okay, moving on. Another thing that is going to change, but not for many people, is plugin ordering. So one constant since the beginning of Kong has been that plugins have been mostly static in their ordering. This has some advantages. The main one is that the order of on which all the plugins are executed can be pre-compiled before even starting Kong. And that is great. It means that when a route arrives, we will have a prepared order already that we don't have to recalculate on every request. The drawback of this method is that it's a bit limited. Sometimes we really need to be able to modify the order in which plugins are defined. And the solutions we have provided so far have been a bit clunky. One thing that we have seen people doing is using the fact that you can create custom plugins to copy and paste the code, the complete code of an existing bundled plugin, just so they could change the property field. Even some people did this more than once, and that was not ideal. So in 3.0, we are introducing a new way of doing things. Plugins can now have this ordering clause without before or after subclause inside. And this is how you would override the default ordering of plugins. So in this case, the rate limiting will happen before authentication, which is completely against the traditional fixed order of plugins and priority, but it can be done now. There is a couple drawbacks with this approach. First, you can probably see this one coming. Now, first one, maybe it's not obvious. Access phase is the only one we are providing support for ordering at the moment. Most plugins do their thing on access phase. Some of them do it a bit later in the log phase. That's probably the second one. We don't want to reorder the log phase. So for now, we are providing support for ordering only in access phase. The second drawback is that there will be some performance impact. As I said, we are still developing these features and we haven't measured exactly how much performance gets impacted here. But the plugins iterator will have to do more work in order to provide support for this new feature. So when it is active, it will slow down a little bit. We don't know still how much, but a little bit the performance. So in critically fast routes, it might not be a good idea to activate this. So a word of caution here. We have not transitioned from a train to a car. We are more or less implementing this kind of thing in Kong at the moment. We are still using mostly trains, but there are some more options. Okay, last thing I want to talk about is deprecations and breaking changes. Some of the breaking changes that we are in, well, first of all, 3.0 is a major release and it comes with some breaking changes. I believe none of them are super critical or difficult to recover from, but there will be some. The ones that are already in master can be seen in our changelog in the open source version of Kong. Later, when we do the official release, they will be released in the official docs, which is the second link you can see here. I can tell you some things that have not been included on the public changelog yet, but are coming, which are the ones at the bottom. There will be some changes in the config file. Again, nothing huge. Fields that have been marked as deprecated for a while will stop working, and we will have some safer defaults on some fields. Not a lot of them, but some of them. Distributions that have been discontinued by their maintainers will be removed from our pipeline. So we will not build any more Debian Jessie packages, for example. And finally, there will be little touches on some plugins. Again, it will be things like removing stuff that has been deprecated for a while, or changing the default value of some configuration option. Instructions about how to recover from each of these breaking change will be included in the change logs as well. Okay, and that is all I have. This is the time to open for the questions.
Thank you. Thank you, Enrique. Thank you, Wangchong. Very, very nice presentation. Let's see if we have any questions from the audience. Yep, we have one from Martin. What's the timeline from 3.0?
I have it written down here somewhere. Let me check my notebook because I know I wrote it recently. I know our target is around May, but I don't know the exact date from the top of my head. I'm sorry. We will publish it soon. That's all I can say. I have seen another one, perhaps, about OpenTelemetry. We have done an integration with Go to feed the Elastic APM suite. How would this work in 3.0? Okay, so I go ahead.
No, actually, if you want to answer that, you can go ahead.
Okay. I think what this person is asking, Ludovic, is that we have support for Go plugins in 3.0, and how will Go plugins work in 3.0? So they will continue working. There is one asterisk on that phrase, which is that if you are using the oldest implementation of Go plugins that we deprecated in 2.x already, that one will not work. If you are using the most recent one, that one will continue working as before. There is another question, which is, can we run one plugin twice in the new release? The answer to that one has to be qualified a little bit. You can already run a plugin twice in the previous releases. That is something that a lot of people don't know. The trick is that it has to be run at different places in the routes, which by which I mean you can run the same authentication plugin twice if you put it on a global scope and then you associate it with the customer as well. Then you will run it twice. It's just that it needs to be, you need to have two different configurations of the same plugin in order to run it twice. But I think the spirit of the question here is, can I add multiple of those to the same customer, for example? And the answer to that one is no, we are not supporting that yet.
Yeah,
Okay.
actually, let me cut here and
Sure.
sorry. Let me also add one for the OpenTime one. So so remember we talked about the new PDK functions we will have in the tracer in 3.0. So all the external plugins will going to support these new PDK functions as well. So you'll be able to get these spans from the our new code base as well. So consider you're collecting these spans on your side, then we are doing this on our side in 3.0. So you're probably getting more granular spans for tracing, and probably, but I'm not sure what's the implication on your side. So you'll likely get more internal details about how come spans on each phase is likely. So, but your existing work will continue to work here, like Enrique suggested.
Okay. Benjamin Berg Zhou is asking, is there a timeline for 2.9 available? I don't think there is one. I think we are going from 2.8 to 3.0. We might have 2.8 point something if we find critical bug fixes that need to be done or security problems, but we are going from 2.8 to 3.0. Okay, the last one is, are there plans, not the last one anymore, are there plans to support secret management with Azure Key Vault? I don't know from the top of my head. I am not the person implementing these features. I know that there are more vaults in the plans for the future, but not for 3.0. For 3.0, we are only starting with the two vaults I mentioned in the presentation. Will the PDK support subscription of the new events? I don't know what that question means. Martin, can you clarify a little bit more? I don't understand what the new events mean.
We also have a question from Tim Kelly in the chat.
Okay.
If you want to look at there.
If you are running Kong using Cassandra database, which has been deprecated, is it recommended to upgrade? Yes. In 3.0, Cassandra will still work. However, in 3.1, 3.2, 3.3, we might introduce new features that will not be supported in Cassandra. So that is the status of the thing. You will be able to upgrade. Cassandra will continue to work, but new features might not work completely in Cassandra. Okay.
So Martin, he describes his question in the Q&A now.
Yes. Okay, I understand the question now. Subscribing to events inside a plugin is not something we do at the moment. And I don't think you will be able to do that in 3.0, but I'm not 100% sure. It might be possible, in fact. Wangchong, what do you think? Can you subscribe to events in a plugin at the moment, right now?
Yeah, so I'm also not very clear about the question. So if you're using the worker events or class events before, and then this will continue to work, you will probably need to using the new events library to replace that to get the similar effect. I'm not sure if you are talking about this one or you are implementing your own events.
Yes, let's separate because there are two things going on here. First one is that what we support for writing plugins is the PDK. So on the other hand, if you just use require in Lua, you can require pretty much any single file in Kong in order to execute it and do whatever that file provides. So in that sense, you maybe should be able to subscribe to events, but we don't support that functionality on the PDK. So as Wangchong said, if you were using the old library of events library to register to events and use the events system, that will not work in the new version of Kong. But it's also not a breaking change because we don't support that on that level on the PDK. However, changing that to the new system shouldn't be super complicated. In our case, what is taking the most time is the tests. A lot of our tests are assuming that when an event happens in a worker, the worker is immediately notified about the event and the others get a notification later. While with the new PubSet system, everyone, including the producer of the event, get notified at the same time. So that change in our way of handling the event means that a lot of our tests broke, and we have to change those. But the interface should be similar, maybe not exactly the same, but similar. Okay. I think there is another question here. Any plans to support service discovery plugins? I don't know there is a plan to do that. I have seen service discovery thrown around in the past. Not for the 3.0 release, though. It was not a priority on this release. But it has been discussed. I can't remember the specifics, I'm sorry. Okay.
Let's see if we have any last questions.
Will the HashiCorp Vault be available on OSS? As far as I know, secrets management is an enterprise-only feature. So the answer is no. I know Apple is in the comments, so maybe he can confirm. Okay, let's assume no. If it's a yes later, then that's happy news, but I think it's only for enterprise.
I can confirm that one. HashiCorp Vault is enterprise only.
Okay.
The only available backend for secrets is environment variables in the free tier.
Thank you.
Thank you, Michael. Let's see. Same in AWS Vault. Any last questions from the audience? No? All right. Well, let's wrap it up then. Thank you so much, Enrique, Wangchong. Thanks, Michael, for helping Apple with the questions. Very much appreciated. We hope to see all of you at our next events. I wish you all a very great day, great rest of your week, and see you soon.
See you.
See you soon. Bye.
Yeah, everyone.